Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have this is nice fourth order equation k minus 4 to the power of 4 is equals to k to the power of 4, and we solve this problem for all the values of k. So you know that this equation has 4 or less than or equals to 4 roots. We need to find out that roots of the given equation. So we move towards the solution of this problem, and here we move the term k to the power of 4 from right hand side to the left hand side, and this will be written as k minus 4 to the power of 4, and this is minus k to the power of 4, and this whole equation is equals to 0. And now further in the next step, here we rewrite this equation as we write this k minus 4 to the power of 4 as k minus 4 square and its whole square minus, we write this k to the power of 4 as k square and its whole square, and this equation is equals to 0. So here we use the nice algebraic formulas to expand this equation, and you know about that. If we have a square minus b square equals to a minus b times of a plus b. So according to this rule, we just expand the above equation as in this form. So we just write this equation as the first factor is a minus b. The value of a is k minus 4 whole square minus the value of b is k square. This is the our first factor, and the second factor is a plus b. The value of a is k minus 4 whole square. The value of b is k square, and this whole equation is equals to 0. And now we divide this equation into the two cases. The first case is we write k minus 4 whole square minus k square equals to 0, and the second case is we write k minus 4 whole square plus k square is equals to 0, and we call this is our equation number 1 and this is our equation number 2. So we solve both of these two equations and we get the values of k. So here first we again apply this nice formula into the equation number 1, and equation number 1 is implies that after applying the above formula, this will be written as k minus 4 minus k into the second factor is k minus 4 plus k, and this whole equation equals to 0. And here we need to add or subtract the like terms. This minus k and plus k are gone, and we get minus 4 times of here this k plus k becomes 2k minus 4, and this whole equation is equals to 0. And now we divide this equation on both of the sides by minus 4 in order to remove this minus 4 from here, and this will be written as in this form. This minus 4 and this minus 4 are gone, and we get this is 2k minus 4 is equals to, this is 0 divided by minus 4 is equals to 0. And further here our target is to get the value of k, and so far this we move minus 4 to the right hand side and we get 2k is equals to plus 4. And for the values of k we divide both of the sides by 2. So when we divide by 2, this will becomes here in this form. So this 2 and this 2 are gone, and we get k is equals to, this is 2 times 2 becomes 4, and we get the value of k is equals to 2. So from first case we easily get the value of k is equals to 2. And now here we need to solve our equation number 2. So our equation number 2 is copied down here. It is k minus 4 whole square plus k square is equals to 0. So we expand this nice formula here, and this will be written as in this form. So this will becomes here. Uh, so we expand this term as k square plus 4 square minus 2 times of k into 4 plus k square, and this is equals to 0. So in the next step here we need more simplification, and we add or subtract the like terms. This k square plus k square becomes 2 times of k square, and here we have 2 times 4 becomes 8k, plus this 4 square becomes 16, and this whole equation is equals to 0. And here you see that each of these terms involve 2, or each of these terms is divisible by 2, so we divide all of these terms by 2 on both of the sides. This 2 and this 2 are gone, and we get here k square minus this is 2 times 4 becomes 8, and we get 4k, plus this is 2 times 8 becomes 16, and we get plus 8 is equals to 0. And now in the next step, here we need more simplifications, and you see that this is a quadratic equation, and we apply here the nice quadratic formula to solve this quadratic equation. And for this, first we write the coefficients of this equation, and its coefficients are a is equals to 1, b equals to -4, and c is equals to 8. And we state the quadratic formula as k equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. This is the our quadratic formula, and here we substitute all the values of a, b, and c, and we get here the other roots of the given equation. So we have k is equals to minus b, the value of b is -4 plus minus square root of b square. B is -4 square, -4 times of a is 1, and c is 8, and it is divided by 2 times of a, and here our a is equals to 1. Further we have minus times minus becomes plus, and this is plus 4 plus minus -4 square becomes 16, and 4 times of 8 becomes 32, and this is divided by 2 times of 1 is equals to 2. And here we need to focus inside the square root sign, and we have 4 plus minus square root of 16 minus 32 becomes -16, and it is divided by 2. So here we break this fraction, we break the square root sign, and we apply this separately on both of these two values, and we get 4 plus minus. We know that square root of 16 becomes 4 into square root of -1, and we apply this 2 separately on both of these two values. So we get this is 2 times 2 becomes 4, and this is also 2 times 2 becomes here 4, and we get here the values are k is equals to 2 plus minus 2 times of this is square root of -1. We know that square root of -1 becomes here iota. So these are the other two complex roots of the given equation, and we have k is equals to 2 be the only one real root of the given equation. So finally we get there are three roots in which two roots are complex and one root are real. So this is our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.